So really, of course, what people want to be able to do is to deploy their own service. So we have some sample services, and let's just talk through what it takes to deploy an application. So if you were with us last week, you saw us deploy some microservices that basically build this image. And they build this path, so to speak. What we have is we have two backend microservices. The orange one is built using a language called Crystal Lang. The green one is built using Node.js. And then the front end application is an app built using Ruby. So what we're going to do is we're going to deploy those exact same applications. In fact, like literally the same code, same applications. We deployed it last week on ECS. Today we're going to deploy it on Kubernetes. That, by the way, is why Docker is so cool, because all this stuff is portable. Once you've built it for once you put it in Docker, it's portable. Changing it and moving it from one orchestrator to the other is pretty easy. Okay, so our sample applications. What we're going to start with is a deployment file. Remember yesterday, if you weren't here, hope you don't remember, but hopefully if you were here, you do. I said that Kubernetes uses a declarative language. We are going to declare the end state that we're looking for, and then Kubernetes just figures out how to get us there. So this is how we declare. This is a deployment. We are declaring what our deployment should look like. It's how this should get rolled out, how it should get updated, where the image should come from, and should we always do Docker pull? Or if we think we already have the image, maybe we shouldn't. What port it should run on. So this is our declaration of what this deployment should look like. So we're going to start off. Let's do the Node.js app first. So we're going to cd into the Node.js checkout. This is what we cloned yesterday from GitHub. And we're just going to kube control apply the contents of the file, Kubernetes deployment and Kubernetes service. So if we take a look real quick, Kubernetes deployment, and you see this looks very similar to what I was just showing you on the workshop page, where our image is coming from, what port it's listening on, how many should we deploy, and so on. And then the same for service. Service declares how do we access this, or how do other things in the cluster gain access to this particular service. And so we're going to set up a listener on port 80, and then we're going to send any traffic to the target port of our container, port 3000. So this is just going to match any application named ECS demo Node.js.
And Brent,
Yep.
someone had mentioned earlier there was a question around CDKs, and I
Mm-hmm.
think this is a good time to bring that up. Where if I didn't want to define, if I didn't want to manage YAML, I could use CDKs because I'm declaring my state, my desired state, rather than doing it in YAML. I'm declaring it in Python or TypeScript, and it will
Totally.
generate that YAML for me, which we can then, kube control apply. So I just wanted to bring that up.
Totally. Oh, yeah, good point. So what we're looking at is like the most basic way to do things, but there are definitely higher levels of abstraction, and CDKs is really catching and coming along as and becoming popular for managing all this YAML. Because let's face it, managing, I mean, it's better than managing JSON, but like it could still be better, right? So I want you to have a good understanding of like what it takes, but then I'm not suggesting that this is what you do in your environment when you start managing many clusters and many applications. There's definitely better things to do. Okay, so we have our deployment, and you can see that sure enough, we have a pod up and running, or we have a deployment up and running, ECS demo Node.js. Remember yesterday I said kube control, the format for the command is kube control, a verb, and then the object. So verb get object deployment. There's also get pod or get pods. And this is, now you can see the pod that is part of that deployment. There's also services, and you can see there's my ECS demo Node.js service and the IP address that it can be located at within the cluster. So this is an internal to the cluster IP address, but if we talk to this IP address, if we could from inside the cluster on port 80, it would route our traffic to any of the running pods that this service has, which currently is only one. Let's do the same thing for Crystal. We've explained it all, so I'm just going to like step through it pretty quick. We're going to build our deployment and our service. We'll then see that the deployment is almost ready, almost up and running. Boom, there it is. And now we'll move on and we'll work on the front end. Now, the front end is slightly different because the front end needs to take traffic from external to the cluster. So right now, these two services, the Node.js and the Crystal service, they are only going to get traffic from inside the cluster because they're back-end applications, right? So that's why they have a cluster address, that address that's only usable from inside the cluster. The front end, on the other hand, needs to take traffic from external, from outside the cluster. So it needs ingress. And what we can do is we can specify the type of service that this is going to have, or this is going to be, and it's going to be type load balancer. So type load balancer means for whatever cloud you're on, go and provision whatever its native load balancing service happens to be. Now, this has been around and part of the Kubernetes API for quite some time. So on AWS, type load balancer is going to go out and provision an ELB, a class, or a CLB, classic load balancer. So let's go ahead and do that so that it can be getting started. By the way, this IAM command is just checking to see that my service has the ability to provision load balancers on my behalf. And if it doesn't have it, then it's going to add it for me. So we want to bring up the Ruby front end now. And there was a challenge. How would you do it? You would CD into the front end checkout, and then you would kube control to apply the deployment and apply the service. And then we can get deployment. This one's going to take a little longer. By the way, instead of up arrow and enter, you can do -W and it'll watch. Now, that one actually happened still so fast that there's nothing more to change. So there's no reason to continue to watch it. But if I had done this, the -W here, once it got to be ready and available, it would have refreshed my output for me. So that's kind of a handy little trick for kube control.
And Brent, I don't know if this is a good time to talk about. And we may talk about this in the later on in the workshop, but is this a good time to maybe talk about like ingress and some of the different options of ways
Yeah,
to
so
expose?
there are definitely different options. ALB is super popular to use for ingress. There's also a new option for app mesh that we just launched. If you want to ingress directly into app mesh, that's available for you now too. Um, for this chapter, we're just going to try and keep it super basic and just like bare bones default. And so that's why we're sticking with, just type load balancer. And let's just go look real quick at the console and we'll see what has come up for us. So if we look at our load balancers in the EC2 console, you see here's this random looking named load balancer a random looking DNS name, and it has 3 of 3 instances in service. It's forwarding port 80 to a random looking port, and it's the security group that it's a part of is my K8's ELB security group. So, and it's if we were to track down that VPC, you would see this is my EKS VPC. So this is the load balancer that got provisioned by my cluster. And I can further see that if I do get service. So just like get deployment, if I do get service, there's my external IP for my load balancer. Look familiar? It looks just like the one here in this console, AEB 735. AEB 735, right? So I didn't have to go and provision that and attach it to the nodes and set up the ports and configure the security groups and all that stuff. Like Kubernetes did that for me. And it knew, hey, we're in AWS. I need to go talk to the AWS API and build a load balancer. And so it just took care of doing all of that for me. So that's pretty cool. So let's do. And by the way, if you're ever on like too small of a screen, another little cube control thing trick is -O wide, and it'll actually A, give you slightly more information, and B, it will expand the width of the output. Sometimes some of these columns will get truncated, but -O wide will prevent that from happening. So if we were to test, it takes a minute for ALBs to come up, but let's actually, whoops, that's not the right commit or not the right thing. Let's grab this URL. Hey, there's our application. So remember I said there's only one copy of any of these things running, but we have our Crystal Lang, we have our Node.js, and then we have our front end, and we're sending traffic. Looks like our front end is running in the third availability zone, and our 2 backends happen to be running in the second availability zone. Total luck that it came up that way. So let's see what we can do from here.
And Brent, a question came in
Yep.
from Raj Roy C. Is do we need to explicitly specify in the deployment YAML if we want an ALB?
Yeah. And there is, by the way, in the workshop, let's just do a quick search, Ingress. And there's a chapter on setting up Ingress controller using ALB. There's some different steps that you have to go through to make this happen. But I'll tell you one of the advantages. Again, we're being very basic right now, and we are building using using type load balancer. But let's scale that thought out for a second, and let's say that I don't only have one um, front end service. Maybe I have like 50 front end services. If I use type load balancer, then at that point, I'm going to have 50 classic load balancers. And the cost for that is like, you know, it is what it is, but it's a lot. Um, Instead, what I could do is actually provision using an ingress controller, using the ALB ingress controller. And ALB ingress controller actually has some other levels of sophistication. I can do host-based matching. So I can have like a DNS name match and route traffic to the appropriate container. Or I can do path-based matching. And I can route anything at slash, app1 to my app1, and slash app2 could get routed to slash app2, and I still only have one ALB to pay for. So for all of that to happen, we walk through that in a later chapter. You can certainly set it up. But again, we're trying to keep it simple in this chapter. So we're just doing classic load balancer for today. And I see Green Knight asks, ALB is cheaper than ELB? Question mark. Definitely check the pricing page. I don't know that in all circumstances it's cheaper, but I think there's a level of scale that you can reach where ELB might end up costing you more than if you were to do the same stuff using ALB. Okay, so we got our services deployed, front end service, found the address. So now let's try scaling the back end services. So, only running one of something is very development oriented. And instead, let's actually build and run multiples of these. So we're going to get deployments so that we can see a before and an after. And you see we have one of each of our deployments running. So then let's scale up our backends, the Node.js and Crystal, and we'll get deployments again. And you see we have three of each of those running and available now. And if we were to go check our application now, check that out. Now you can see that the traffic is actually, moving around. So still only one front end, but it's sending traffic to multiples of our backends. So we have redundancy. So if we were to lose one of our backends, we would still be able to serve traffic to our customers because we have more than one backend. Let's do the same thing for our front end.
And that was quick, by the way. Like
Oh,
like you issued that command, and within seconds, your services are up and running. So that's something to highlight. That's just one of the
yeah.
benefits of using an orchestrator like Kubernetes. It's just fast.
It is. It's fast, and it had to pull down the container from Docker Hub. So, like, yeah, it's pretty impressive how
Yeah.
fast things happen. And that's actually it. It's kind of a neat call out. One of the biggest differences between ECS and EKS, this kind of highlights it. EKS, it's one orchestrator per cluster. And so issuing a command to it can queue up that action and it can execute that action virtually immediately. ECS, on the other hand, is an orchestrator for the entire region. So it is incredibly massively scalable. If you had to scale to, thousands and thousands of nodes and hundreds of thousands of containers, ECS can do it no sweat. It's not something that Kubernetes is ready for today. So, that's a situation where instead you'd probably build out, dozens and maybe even hundreds of Kubernetes clusters to manage all of that for you. And then you'd be in the situation where you'd be firing those commands to dozens or hundreds of API endpoints. So it's totally situational what's going to work best for you. I said yesterday, one of the advantages of Kubernetes is that it scales to be super small. You can run the whole thing on your laptop. ECS, on the other hand, I didn't say this, but it's the opposite. It can scale to be super massive and can handle scale that right now Kubernetes just can't do. So it's totally up to what is the best situation for you, and that should be part of the decision making process. Okay, so we're going to scale our front end service now. We'll do the same thing, get deployments to see a before, then we'll scale it up to 3, and then we'll do a get deployments to see an after. And actually, I'm going to add on a -w there. So you see right now 1 of 3, so and only one available. Once we get our second and maybe our third, see there's our second and there's our third, and they're available now too. So I watched, and it told me when those were ready to go. So I didn't have to up arrow and enter and recheck. And if I go and I check my application now, you see I'm sending traffic now to all 3 front ends as well as all 3 back ends. Cool.
Nice.
So We're going to finish by cleaning up the application, and then we can close out with any questions that we have.
Cool. And you know, it's good time. Like your timing's perfect because, yeah, we're almost at the top of the hour here, and I didn't even realize. Truth is, I haven't looked at the clock, so the timing was
Nice.
perfect.
That's so cool. Um, how are you simulating that traffic? I'm not. That was real traffic. So like if I've just deleted the services now, so it won't work anymore. But if you were to actually send traffic to this same URL, you would get these images too. This was live on the internet, and this was actual traffic and not simulated. So I just have my browser refreshing. So it's every request going to a different front end.
And did you see that question from Green Knight that just came in?
Yeah, so we did use EKS control. Definitely check out the beginning of this video. EKS, and we walked through some of the cloud formation that EKS control built. Well, we didn't walk through it. We just walked through the fact that it exists. But we took a look at it, and looked at where you could go and dive deep and see where the cloud formation is and what's in it and stuff like that. So definitely check that out. Check out the video if you missed the first part of it. Come back tomorrow. We'll be here at the same time, and we're going to pick up where we left off. We had our microservices deployed, so we're going to be taking a look next at templating using Helm, and we're going to go and deploy services again. This time parameterized using Helm.
Perfect. Thanks, everybody. We will see you tomorrow, same time, same place.